Hello, hi, it's Henry the Computer Guy, and welcome to our lesson number 43. And in today's lesson, we are actually going to be talking about the measurement of storage capacities. For example, if you have for example, the memory card, if you have, let's say, the hard disk, if you have a flash disk, those devices or components have their storage capacities. So how do we actually measure them? For example, you might be having a memory card, let's say when it is having 1 GB, having a flash disk, let's say having 4 GB, you have a hard disk, let's say it is having, let's say 120 GBs. How do we actually measure those storage capacities? Or you might be having, let's say, your phone and you buy your internet data. How do they actually determine the data they are going to give you? Or why do they actually give you, let's say, 1000 MBs if you, let's say, buy 1 GB? So these are actually what we are going to be looking at in this lesson. And they're telling us that in a computer system, data is represented using the binary system, which is the combination of binary digits. So specifically, a computer understands what we call a machine language. And that machine language is a combination of ones and zeros. That's why we call it a binary language or binary system. It is composed of only two values, the 1 and a 0. Actually, those two values are called the bits. In full, it is binary digits, but we always shorten it to what we call a bit. So specifically, when you issue any instructions to a computer, it will have to change those instructions into the language that it understands. And computers understand what we call a binary language. So it will convert everything or any instruction you issue to it to the language that it understands, which is the one of ones and zeros. So there are only two binary digits, 1 and 0. These digits can be arranged in such a way that they represent characters, they represent digits and other values. So all those ones and zeros can combine to form either a character or a digit or any other type of values that we shall be seeing in our lesson to come. So let's look at some of the data storage units. And they're telling us that data storage has various units, including, so first of all, the smallest unit we have is what we call a bit. So what is a bit? A bit is specifically the smallest unit of measurement or computer memory. And we say that that one is either the 0 or the 1. Whenever we talk about a bit, we mean either the 0 or the 1. So we also have what we call the bytes. So if we combine 8 small bits, they will form what we call a byte. So if I have my bits when they are 8 in number, I form what we call a byte. And when we continue, if I contain or combine 1000 bytes, then they will form what we call a byte, a kilobyte. And again, if I combine 1 million bytes, then they will form what we call a megabyte. So if I combine 1 billion bytes, then they will form what we call a gigabyte. So like that, like that, like that. So if I combine 1 trillion bytes, then they will form what we call a terabyte. So we're going to be looking at how those ones come about. So they're actually telling us that therefore, storage capacity refers to the specific amount of data that a device or system can accommodate. For example, if you have your CD, it will be indicating, let's say, 700 MBs. If you're having, let's say, your DVD, it will be indicating, let's say, 4.7 GBs. So that amount of data that a device can accommodate or hold is what we call the storage capacity. So it refers to that amount of data that a storage device can actually accommodate or hold. Let's continue. And they're telling us that units of measuring computer memory. So they're telling us that the smallest unit of measuring computer memory is the binary digit. So what is a bit? A bit is the smallest unit of computer memory. Either that 1 or that 0 is the smallest. So we begin from that 0 or 1. So when they combine, they go on increasing. So binary digits are the numbers 1 and 0, which can be represented in a computer by switching voltages on and off. So those two values, either the 1 and the 0, have states. 1 representing on and 0 representing off. So whenever you see those values, they have the two states, which is on and off respectively, 1 and 0. So when we combine the 1 and 0, 8 in number, they form what we call a byte. So 8 little bits make up what we call a byte. And another name for a byte, it can as well be called a character. So anything that I always type onto my computer keyboard is a character. For example, when I type A, when I type B, 1, 2, 3, question mark, a space, full stop, all those ones are called bytes. Or it can be a character. But remember, we have said each of the characters or byte contains 80 bits. For us to have a byte, you have to combine 8 bits. So each number or each letter I type onto my keyboard is a byte or a character. But that character consists of 8 small bits. Now, after getting my byte, which is a combination of 8 bits, and I divide that by 2, it gives me 4 bits. That means that we form what we call a nibble. So a nibble is a sequence of 4 bits or half a byte. Then we have what we call a word, which is a unit of data of a defined bit length that can be addressed and moved between storage and the computer processor. So specifically, a word is a combination or a sequence of 32 bits or approximately 4 bytes. Remember, when I talk of 4 bytes, it is 4. That means that each of these contains 8 bits. So if I get 4 bits, that means that each of these 4 bytes consists of 8 bits. So I'll get my 4, I multiply by 8 to get what we call 32. So a word is specifically a sequence of 32 bits. Then when we come to what we call the word length, or word size, or word width, it is the same. And it is the number of bits in a word. For example, I'll ask you that how many bits are in the name, let's say, computer, or are in the name, let's say, called Henry. So what you'll do, you'll have to count those characters or bytes, then you multiply by 8. That will give you the number of bits in a word. We shall see that one in an example to come. So the storage capacity of computers, specifically RAM and ROM, and remember RAM in full is random access memory, whereas ROM is read-only memory. The difference is that RAM is always volatile. It loses data when power goes off, whereas ROM is non-volatile or permanent. That means that it will retain the data even if power goes off. So the reason as to why it is called read-only memory, it cannot be modified. So they are telling us that the storage capacity of computers, in bracket RAM and ROM, or other auxiliary storage units like the D6, or those external storage units like the D6, are generally given in what? In bytes. So I don't care whether it is either the kilobyte or megabyte or gigabyte, all of them have something in common, which is a byte. So the storage capacity of all the storages that we are having is either given in bytes. You will be having, for example, kilobyte, megabyte, let's say gigabyte, let's say terabyte, petabyte, and others as we are going to be looking at them. So that means that all the storage capacities are given in bytes. We continue, and they're telling us that we have to note that 1 byte stores approximately 1 character. If I say byte A, that is A, it is a byte. That means that it only stores 1 character at a time. So that means that a byte is the same as a character. But that character consists of 80 bits. So that means that in a byte, we have small 80 bits. Let's continue. And we summarize them. So more units of computer memory, they're telling us, of course, we said we begin with, let's say, the bit. After talking about the bit, we went to what we call a byte, which is specifically a combination of 8 bits. So we are going to see how we go on increasing our storages. Then when we come to what we call a kilobyte, so this is going to be the order in which the storage capacities move. From byte, we come to kilobyte. So a kilobyte is specifically abbreviated as a KB. And it is always 2 to the power 10, which gives us 1024 bytes, but approximated to 1000 bytes. So someone can say that a kilobyte is equal to 1024 bytes or 1000 bytes. So they are actually removing those other, let's say 24, and approximate it to 1000. Then when we come from after the KB or the kilobyte, we come to what we call the megabyte. And the megabyte is specifically 1 to the power 30, which is 1024, then times the previous we have talked about, which is the KB. Or approximated, which is 1000 KBs. Are we seeing? It goes on increasing. So the first one was actually the byte. After the byte, we went and said that if you combine these bytes and they become 1024 bytes, it forms what we call a kilobyte. So when you get 1024 KBs, they form what we call a megabyte. Or you can approximate it to 1000. Remember, we say that a question can come when it wants you to use the scale or use the scale or use the scale. So it goes on depending on the question that you already have. But they always approximate it to 1000. Are we together? So it is specifically 1 megabyte giving us 1024, then the previous. Or we approximate it to 1000, then KB. Then which is that. And remember, these storages go on increasing by 3 zeros. So the first one was 1000, then we always come to, when we add there 3 zeros, it becomes a million. So when you read this one, it is just 1,048,576 bytes, but they always approximate it to 1 million bytes. So these others are made or are zeroed. So that means that actually, if we look into this, these values are left out, yet they exist. So that means that they are actually being, or they are cheating us. So when we come to a GB, 1 GB is specifically 2 to the power of 30, which is approximately 1024 times the previous, which is MB. So it becomes 1024 megabytes, or approximated to 1000 megabytes. That's why on your phone, when you buy your data, let's say you have bought 1 GB, they will indicate it as 1000 MBs. So they don't include in some of these values. And if you write it in this case, then it will be like this. And that one takes us to what we call a billion. So we began with actually 3 zeros. We added other 3 zeros. It became a million. We added other 3 zeros. It became a billion. So we go on increasing them with the 3 or by 3 zeros. Then that one takes us to what we call a terabyte. And a terabyte is specifically 2 to the power 40, which gives us 1024 then times the previous, which is the GB. Or it is approximated to 1000 GBs. So a terabyte is 1000 gigabytes. Or you can even write it as this. You can put that one on your calculator, it will be giving you those answers. Or that one can actually be zeroed or approximated to what we call 1 trillion. So all these other values inside here or at the end are made to be zero. So it's like they are now cheating us. So those are telecom companies. They give you the data, but when you buy your 1 GB, they're not going to include in these other values. They will just give you your 1000. Let's say if you buy a terabyte, they will give you 1000 GBs. If you buy 1 GB, they will give you 1000 MBs. That's actually how they are counting them. Then after a terabyte, we go to what we call a petabyte, and that is a 2 to the power 50, which is 1024 then times the previous, which is the terabyte. Or 1000 terabytes give us what we call a petabyte. Or if you put it on the calculator, it will give you this. Then that one is actually made to be a quadrillion. So they add more other 3 zeros from 1000 to million to billion to trillion, then quadrillion. So let's also look at some other higher prefixes. So from a petabyte, we come to what we call an exabyte, and that is a 2 to the power 60. So you go on doing the same like this. That means that the exabyte will be 1 1000 petabyte. Then the zettabyte will be 1000 or 1024, then exabyte. Then the yottabyte will be 1024 zettabyte. And we come to what we call a brontobyte, which is a brontobyte, which is also 1024 yottabyte. Then actually we can stop on the gyopobyte. Are we together? Which is actually the 1024 brontobyte. And this are actually termed as a quintillion, sextillion, septillion, octillion, and nonillion, respectively. That means that you go on adding three zeros up to that level that we are having. Are we together? So you go on adding 3 zeros. Let's say from 1000, 1 million, 1 billion, trillion, like that. That means that whenever we increase in sizes, we go on adding 3 zeros. Or you can use any of the skills that you're seeing there. Now they're telling us that in conclusion and in computing, they're telling us that the approximation of 1024 to 1000 has brought about confusion, and many manufacturers quote a DISC with this, let's say 1 billion as or instead of this one. That means that they are zero, or they are making these other values to be zeros. That means that they are actually cheating us. So all that storage capacity is not included there. So all of them are quoting their storage capacities as this. So they always put or approximate those values and remove them. So we are actually losing out some spaces onto our storage capacities. So it's been Henry the Computer Guy, and I thank you for actually giving me your time. So please subscribe to my channel and let's say help me and share my link to other people who might need it. So bye bye. See you in the next video. I sign out.